Emma King 4, Factoring Special Cases. All right, so you have learned how to factor in many different ways, and this is the final section. This is basically going to talk about ways to recognize patterns to save you a lot of time. So let's start with a few review vocabulary words. Difference, which of course is the answer to a subtraction problem. Squares, which is the number that is a result of a number multiplied by itself. So if you think back when we learned about squares, it's, 2 times itself gives us 4, or 3 times itself gives us 9. So it is when it is multiplied by itself. A perfect square is a number that can be divided into 2 factors, and those factors are the same number. Quadratic is the name for a polynomial when the highest degree is 2. So you remember quadratic is when the x has a little 2 exponent above it. And trinomial is a polynomial with 3 terms. Binomial is a polynomial with 2 terms. All of these vocabulary words help remind us what we're looking at today. And then when you look at, in the explanation, when you look at the names of these different patterns we're looking for, they have a lot of those words in them. So these are shortcuts. Shortcuts are awesome. They don't take long, and they help us to do something in a lot less time and a lot less complication. So the first one is called the difference of 2 squares. Well, difference is subtraction. We know what squares is. It's a number that is can be factored into 2 exact same numbers. So that means you see 2 perfect squares in this pattern, and you realize that the middle term is missing, and there's a subtraction sign in the middle. So you're only going to have 2 terms. They're going to be perfect squares, and there's going to be nothing in the middle, and it's going to have a subtraction sign. I'm going to jump down to the sum of 2 squares. That would be the exact same thing, except there's an addition sign in the middle. You'll see examples of this in a minute. But when you have 2 squares with x's and there's no middle sign, but there's a plus sign, you cannot factor those. So you would write the answer as not factorable or unfactorable, or no solution. So you've got 2 that look the same except for the sign that's in the middle, which changes them. Then we've got a perfect square trinomial. That means there's 2 perfect squares, a middle term, and 2 addition signs. So this is all being added. And that can be factored very easily. And finally, we have grouping. Grouping is pretty cool. It's basically what you just were doing when you were doing the swing method. You were basically just finding like factors that were common in sections of the polynomial, and that's what we will do for grouping. So let's look at these examples because it's much easier when you see it. So we're starting with example 1, and I look at it and I see 2 terms, and both of those terms are perfect squares. 9 is a perfect square, 25 is a perfect square. You do have to kind of know your perfect squares. We did review this a little bit earlier in the units, not this unit, but way back. But if you need to go back and review that, that would be good to do if you're a little rusty with those perfect squares. But just as a quick review, if you remember, you would start with 4, then you'd have 9, 16, 25, etc. So you want to know your perfect squares. But when you recognize that there are 2 here and a subtraction sign in the middle, that's going to be, let's look back, the difference of 2 squares. Basically tells us what it is. So all we have to do is say 3x and another 3x. Because our middle term is missing, that means we would have 1 plus and 1 minus, because that's what makes the middle term cancel itself out. And then what would happen to the 25? It's going to be 5, because we know that the factors of 25 are 5 and 5. And that's it. That is how quickly you can factor the difference of 2 squares. Let's jump to example 4, because this is the sum of 2 squares. Well, we already said that was not factorable. So guess what? This one's finished already. No solution. Because there's your plus sign, and there's nothing I can do that's going to make that middle term disappear if there's a plus sign there. If there's a minus sign, I can, because I know that one addition and subtraction would cancel each other, and then the multiplying those 2 together would give me that minus sign in the middle. So if you see this addition of 2 squares, not able to be solved. Let's look at example 2. I see that I have a trinomial, okay? And I see that 4 is a perfect square and 9 is a perfect square, but I'm a little concerned about this 12 in the middle. Well, the good news is you don't have to worry about it at all. The 4 is factored into 2. The 9 is going to be here as a 3, and all we need to do is repeat this. But what if this doesn't seem right? Let's check it. 2x times 2x, 4x squared. 2x times 3, 6x. 3 times 2x, another 6x. And 3 times 3, 9. So I can check it. I can always check it by using the multiplication method, either FOIL or whatever it was you preferred when you learned how to multiply binomials. All right, example 3. So this example 2 was perfect square trinomial. 2 perfect squares, a middle term, and 2 addition signs. And finally, this is probably going to be grouping. So let's take a look. There's definitely more than 3, so it's not a trinomial. I see a 3 here as an exponent. That's interesting. So here's what we do for this. We literally take a line and divide it right down the middle. We take this and we think of it as a normal polynomial that we're going to use GCF to factor. So what do I see that's my greatest common factor in here? 24 and 16 have 8 in common. I think that's the largest number. So we'll put 8 out here. X cubed and x squared. Well, the biggest exponent there is squared. The biggest that's in both of them. Because if I do cubed, it won't work for this one. So I have to choose really the biggest exponent that's in both of the variables. So 8x squared, and then I'm going to do a parentheses. Remember this from greatest common factor in the very early part of this unit. What's left if I take 24 and divide it by 8? 3. What's left if I take x cubed and take out x squared? I'm left with x. All right, so now I'm looking at 16x squared. If I divide that by 8x squared, I should just get 2. So that's the first half. Now we go over here. What is my greatest common factor between 15 and 10? 5. Can I put x? No, because it's not next to the 10. So parentheses, 15 divided by 5 is 3x. 10 divided by 5 is 2. What do you notice? You should see that these are exactly the same. Whenever we do factoring by grouping, these numbers should be exactly the same. These, not numbers, but these terms in the parentheses. And whatever's outside, we take this and we bring it over here. And that's one of our parentheses. And we only need one of these to tell us that's the other factor. I know I went through that kind of quickly, but really, because you've already done the other units, this is the simplest one. So look back, rewatch if you need to, but basically, you're ready for your exit ticket. Congratulations. Have fun.